Hello, yeah, this is a new video about using Excel to solve linear programming problems. And basically, we're going to use Solver to do this. Solver, just to know, it comes standard now with Windows, actually with Excel 10. If you don't have it or if it doesn't show up on your computer, you need to add it to your add-ins. So if you go if you click on data analysis, you see data analysis there, and there will be a solver right before that. If you don't have it, you have to go to add-ins and add this software to Excel. uh, okay, so the problem we're going to use is from your textbook, chapter 7. It's in section 7.1. It's called the RMC problem, and I'm just following the notes in Appendix 7.1 on how to use Excel to solve this linear programming problem. So the problem is basically we have three materials, and I have set it up here so you can follow what we have, and setting it up, adding all this information in Excel helps you understand the output when you get the output and the report from Excel. So that would be easy to, it's a good way to design your problem. So the problem, we have the material requirements. We can, in this one here, we can produce two products, fuel additive and solvent base. To build 1 ton of fuel additive, we need 0.4 tons of material 1 and 0.6 tons of material 3. To create 1 ton of solvent base, we need 0.5 tons of material 1, 0.2 tons of material 2, and 0.3 tons of material 3. We have 20 tons available maybe per day of material 1, 5 tons of material 2, and 21 tons of material 3. And we also have the profit margins here. We have $40 per unit profit, and this is 30, and we want to find out how do we what's the product mix of these two items that maximize our profit. So now, how do we set up the problem in Excel? That's what we do this first setup. Now we're going to build the model. I have the decision variables here, and I have two decision variables: how many tons of fuel additive to produce and how many tons of solvent base to produce. And so I have these are the decision variables, go in here and here. I put 0 here and 0 there, and we want to maximize the total profit. Just leave spacing to make it look nice. So this one here we're going to have to build, and you can see it's going to be B8 times B15 times B15 here plus C8 times C15. So that goes in here. Now we're going to do build the constraints, and the first constraint is going to be, of course, this material. So let's build it here. So say equal, and that's going to be this times this quantity here, tons produced, plus this times the how much we produce of this, then, and this should be less than or equal, so we need less than or equal a quantity here. But since these other two constraints are the same, I just wanted to click here and oh, oh did I oh I should didn't do return, and now we go there and build the other two same way. So if you click here, you can see that I have B6 times B16. Oh, I should have this should be 15. Oh, so I have to change that, and that should be C15. And same thing here, this should be 15, and this should be 15. So my constraint is basically this times this plus this times this, and it should be less or equal to these amounts here. So the first amount here should be equal to this, which is D5. There's have to be 20, and if I do the quick button, I get all the equations, and so that gives me all the equations here. And you probably notice that this is slightly different from the one in the book, because once you build these equations, you get all these values of zeros. That's your, we start with 0 values, and we're going to let Excel give us the answer. All right, so now we've done this, build the model. We're going to solve it. So we're going to go to Excel solver, click on data, go to data analysis, go to Excel solver, and click on solver. I already have. So we're going to set the objective function, and that's going to be this set here. So if I didn't have here, so it's going to be B17. You would want to add that first there, and the second thing, you want to add the max here. And then we want to add the constraints here. So we're going to click add and add the constraints. Since I have them probably, so it's B20 to B22. All these less or equal to D20 to D22, and let me see if I remove them and set them again. Yeah, so if I go in here, I say add constraints, so that's going to give me the cell reference. So I go in here and click the way here. I can change this to greater or equal or less than or equal. If some of these constraints are less or equal, greater or equal, I have to do it one at a time, so I can group them together. I go here and I want this, and I go all the way here. I click OK. On, oh, did I make some mistake somewhere there? So let me go back on this. All right. Did I? Oh, there's some mistake there. That should be B21 here. How did I get 20? Oh, 20. Oh, yeah. Oh, this should be start with 20. Okay, that's 20. Okay, and we are set. So now we want to make sure that check this to make sure that the unconstrained variables are non-negative. Select a solving method. We pick the simplex because this is a linear programming problem, and so I'm going to click solve. Sometimes we may want to go to options. Say I want to see if I want to do an integer programming problems, I can make some of my variables integers. I don't want to do that, but so I'm going to go back to this. What else? What are other options we have here? I'm going to say solve, and And now keep solver solution, yes, and so I want the answer, and I want sensitivity analysis. I want more than what's in your book, so they'll show you the things, so you can also keep this and get this. The limits, I don't know, it's not that useful, but let's show everything and click. Once you're done, you click keep solver solution, yeah, click OK, and boom, we got the answer. So now we have the answer here, which says produce 25 tons of fuel additive, 20 tons of solvent base for a total profit of $1,600. So that's my answer report here. This is a report from the simplex, which gives me again the values, the final value 1600. This is the amount to produce, and tells me which constraint is binding, which one is not binding. So the first and the last are binding, the second one is not binding. And so I go to the sensitivity report, which is the next chapter, and I have here again I have the amounts produced, the I have the reduced costs here. Since both products are produced, the reduced costs are 0. These are the objective coefficients we had given, 40 and 30. The allowable increase and the allowable decrease for this reduced cost. So I can increase these and decrease them. I can increase this by 20 or go down by 16 and still have a reduced cost of 0. That's what that means. Same thing here. In this report here, so these are my final values, how much we used on the right hand side. So we used 20 out of 20, that's why it's binding. We used 4 out of 5, so tons is not binding, and this is, we used all of it. So the shadow price of this is positive, this is 0, and this is positive, so it's $33. So if I had 21 here, that would add my profit from 1600 to 1633. Same thing here, if I add 1 unit here, I would go again by 44.44. So these are the right hand sides. You can tell which one is binding, which one is not. Allowable increase, so this shadow price is valid in this range from 20 up to 21.5. so you add or down to 14. So that's how much you can decrease, and before this before the shadow price changes. And the same thing here, the shadow price will be 0 if you keep increasing this all the way, that means to infinity, or if you go down to 4. If you go below 4, then your shadow price will become positive, and same interpretation here. Okay, so I hope this video has been helpful, and thank you.